more example to finish this up. In this question, we're asked for each function, state the parent function and the transformations required. So going a little bit backwards, now I have that g at x with all the numbers in place. I need to first identify which of the parent functions was this. So here, I hope you can see that my parent function is coming from that squared there. So I'll say that my parent there's my x squared function. And next I'm going to state the transformations. So what happened to that x squared function to give me 3x squared plus 2? What would I have to do to the graph? And so my transformations. First, I always start by looking at my multiplier. My multiplier here is 3, so I'm multiplying x squared by 3. That tells me that I have a vertical stretch and the factor is 3. Next, just moving through my function, after the x squared, I have a plus 2. Now the plus 2 comes after the squaring. It's not inside the square function, it's outside. So that tells me that it's vertical and it's addition, so it's a vertical shift or a vertical translation. Don't forget to tell me which way you go and how far. We're going to go 2 units up. So that's it for the first equation. Moving on to the second equation, we need to identify our parent function. So again, I'm looking at what's going on with the x, and I notice that the x is in the denominator this time, and that reminds me of my reciprocal function. So I know that my parent function is 1 over x. Next, I'm going to state the transformations. This is kind of a weird one because they've multiplied that a value into the numerator like we did in a couple of our other examples. So remember that that -2 was multiplied in, and that's actually my a value right here. My a value is negative, so that tells me that there's a reflection in the x-axis or a vertical reflection. The 2 in my a value tells me that there's a vertical stretch. And the factor is 2. Then I'm going to move into the denominator. Now I'm adding 1 with the x inside the denominator. And I know if I'm adding or subtracting inside the function that it's a horizontal change. So I know that there is a horizontal, and because it's adding, I know it's got to be a shift or a translation. So there's a horizontal shift. Horizontal is kind of tricky because it's always the opposite of what it looks like. So it looks like I'm adding 1, so I know that instead of going to the positive side, I'm actually going to go to the negative side or the left. And I'm going to go over 1 unit. And then the last thing I need to think about is that -3 outside the denominator or outside the function. And so I know that subtraction outside the function means that I have a vertical shift or a vertical translation. And this time I'm going to go down because it's negative, and I'm going down 3 units. And that's the end of that function. For our last example here, we have to identify the parent function. And I hope you're noticing those bars, right? That's what makes this one a little bit different, those bars here, and that's my absolute value function. So I know that my parent function is the absolute value of x. So just picking out one of those basic 5 from your handout 2 days ago. Now what I need to do is describe the transformations. So again, I'm going to start with the multiplier. I was thinking about BEDMAS, right? Going through multiplication before I do addition or subtraction. So I have a multiplier out in front of my absolute value function. It's outside, so I know it's definitely a vertical change. And it's multiplying by 1/2, which is smaller than 1. So that tells me that the graph is actually going to compress in vertically. So it's going to get flatter. So I have a vertical compression. And that factor that I'm multiplying all the y values by is a half. So I'm going to use a factor of 1/2 here. And then just moving along through my function, I'm moving inside the absolute value bars, there's a subtract 5. Because it's inside the function, the absolute value function, I know it's a horizontal change. So it's a horizontal shift or translation. I know it's a shift or translation because it's adding or subtracting. And I'm going to go the opposite direction. So it looks like -5. That means I have to go over to +5 or 5 units to the right. And then the last one outside the absolute value function, I have adding 3. So that tells me outside the function it's vertical. And because it's adding, I know it's a shift or a translation. And I'm going to go 3 units up. All right, that's it for your lesson today. Make sure you pause, rewind, go back over everything that you need. And the supply teacher has a handout for your homework. Have a good day.